The more we understand about even and odd functions, the easier we have at finding definite integrals without having to do a lot of work. So for instance, if we can recognize when a function that's given to us is symmetrical about the y-axis, then we'll recognize that it's an even function. So symmetrical about the y-axis is an even function. And when you have an even function, if f is an even function, meaning it has that symmetry about the y-axis, then the integral from negative a, we'll say this is negative a and this is positive a. The integral from negative a to positive a of f of x dx is equal to 2 times the integral from 0 to a of f of x dx. So having practice with one of your lower limit being a 0, when your lower limit's a 0, you're going to be subtracting out 0. So you'll have your f of a minus f of 0, which will be 0. So you'll end up with just your f of a. And in this case, you're going to take 2 times that f of a. It's a cool thing. Now, when you have an odd function, you have symmetry about the origin. So you have your graph being symmetrical about the origin. And when that happens, you've got the same exact amount sitting above the x-axis as you do below the x-axis. Whereas on the left-hand side, when we had the even function, you had the same exact on the left as you did on the right, therefore you were able to double it. Over here, on the odd function, remember, this negative amount will be the exact opposite of this positive amount. So what that looks like is if f is an odd function, if f is an odd function, then your integral from negative a to positive a, we'll say this is negative a, and we'll say this is positive a. From negative a to positive a, f of x dx is equal to 0. So let's do a couple of examples so that you can see. Example number 8. On the left-hand side here, x squared is an even function. On the right, x cubed is an odd function. When you can recognize your even and odd functions, negative 2 to 2, our lower limit of integration is the exact opposite of our upper limit, which means we're going to have the same half on the left as we do on the right of the y-axis. Therefore, we can rewrite this from 0 to 2 with a 2 on the outside. We're going to be doubling the half that we're evaluating. That's going to be 2 times the quantity x cubed over 3 evaluated from 0 to 2, which will be 2 times the quantity 8/3 minus 0/3, which is 16/3. And that's that 0. When you evaluate for 0, you end up with 0/3. Now the odd function, once you recognize that you have that odd function, the integral from negative 2 to 2 of x cubed dx is equal to 0. There's no calculating. Not to worry though, if you don't recognize the odd function, you're just going to be doing a little bit more work. You'll have x to the fourth over 4 evaluated from -2 to 2. When you put a 2 in, you're going to get 16 fourths minus, then when you put a -2 in, you're still going to get 16 fourths. And you'll just say, oh, nuts. I wish I would have remembered that that was an odd function, because then I would have saved myself some work, but you will still get the correct answer of 0.